Alright, so today we're going to discuss naming simple organic compounds. Previously we've talked about naming ionic and covalent compounds, so today we're going to discuss just basic organic compounds, nothing too fancy, it's keeping it very simple. So the first question we have to ask is, what is organic chemistry? Simplest answer is the study of carbon. Now, there are other classes that focus on strictly organic chemistry, but in here we're just going to focus on very simple things such as naming compounds. We won't talk about any reactions with organic compounds. So now just a recall from previous is that we have to understand the difference between ionic and covalent, and so we can move forward in organic. Just remember that ionic compounds contain metals and nonmetals and are attracted to each other by transfer of electrons, hence creating the ionic compound. Covalent compounds are caused by two nonmetals sharing electrons together. Organic compounds are a special type of covalent compound. They're formed through covalent compounds, but they possess a different set of rules as compared to covalent nomenclature. So remember that covalent compounds, you have to use prefix to state how many of each element are present. So organic is similar, but it's a little different. So now in this particular video, we're just going to discuss simple alkanes. Recall that an alkane is just a simple carbon chain that where all the carbons are single bonded to each other. So a good example, most common example would be methane. Methane has two parts to it. Now this is the part where we get into the nomenclature aspect, and that is the suffix versus the prefix. Now the suffix itself suggests that the carbons are single bonded. Notice that you have the A&E, which I'll circle here and up here. This is what tells us that we're dealing with an alkane. The other part is that we have the prefix. Now the prefix here is meth, and the meth part will tell us the number of carbons that are present in that molecule. Now, as far as the prefixes are concerned, we have 10 different prefixes we're going to focus on in this video, and they're listed in this table here. So I would suggest you at least make sure you remember these and the number of carbons. So when we talk about methane, we are referring to the fact that there's one carbon present in that molecule. The same thing goes for eth. Now eth has two carbons, and I'm just going to continue down the line here for prefixes. Prop is 3. Now you've probably heard of prop before, being propane or propanol, ethane, ethanol. So these are common words that you probably heard somewhere along the line. Gasoline, gas, it's butane, bute, that's 4 carbons, and that's found in cigarette lighters. It's the fluid that they use. Then you have penta, which is 5, hexa 6, hepta 7, octa 8, nona 9, and then last but not least deca, which is 10. Now again, remember that these prefixes will tell you the number of carbons. Now we're going to look at just a few examples, and so we've kind of touched base on this already, but we're going to just draw out a couple examples. Now, one thing I want to do is make sure you understand that when you look at the name, you oftentimes will be given the prefix and the suffix. So in this case, you have meth and you have ane. Now we just learned that meth has 1 carbon, and so we can draw our carbons, and remember that there's an octet rule. So you're going to have 4 dots that goes around the carbon, and then to finish this off for the A and E. Now we don't have to worry about the ane part because there's no other carbons to bond to here. So we're just going to simply fulfill the octet using hydrogens. So we're just going to draw 4 hydrogens around the carbon here. And so there we have methane. Now from this Lewis structure we can achieve the formula, which is CH4. Next we have propane. Now propane, how many carbons does that possess? Well, 3. Yep, you're right. So you got 1, 2, and then 3. Now you see how we have the single bonded carbons here. Now we still have to fill the octet. So you have 1, 2, 3, 4, 5, 6. Alright, so now adding the hydrogen, just like we did on methane here, we're going to have, this will achieve the octet for this carbon. So you got 1, 2, 3, 4, and then each bond carries 2 electrons. That's 8 total electrons there, so that achieves that octet. And you'll do the same thing for the other two. So you have 2 hydrogens on the middle carbon, and then 3 hydrogens on the right carbon. Now the formula for this is going to be C2H. You can count them up. That's 8. Another way you can figure this out is you're going to have the number of carbons times 2 plus 2. This will work most of the time, but not all the time. Now octane has how many carbons? Alright, 8 is correct. So if we want to do the real quick formula of this versus drawing the Lewis structure out, it would take pretty good while to draw the Lewis structure, but it can be done. So there's 8 carbons. 8 times 2 is 16 plus 2, so that's a total of 18 hydrogens. So the formula would be C8H18. Now you can do this for any of the number of carbon chains that we have listed previous with the different prefixes, meth, eth, prop, bute, and so on. But we're going to look at another. We're going to add on to this. We're going to talk about what is an alcohol. So now, an alcohol is an organic compound that contains an alcohol group, which is a functional group, and has the formula of ROH. So we have the OH here. Alright, now just we can't get confused with the difference between an OH being an alcohol versus the hydroxide, which we saw in ionic compounds. This here is not an alcohol. Alright, this is not an alcohol, so do not confuse the two between each other, okay? So an alcohol is something that's going to be covalently bonded to a carbon, and that carbon can be some number of carbons in a chain. It doesn't matter. It's the fact that it's bonded covalently to the carbon. Now we can look at a couple different examples. These are very common examples that you might see. One, in fact, you use at your house and it's called rubbing alcohol. And so we're going to look here. So 2-propanol is a good example here for that. Now let's dissect the name itself, propanol. All right. So prop suggests that there are 3 carbons. The A and E again suggests that it is single bonded, and then finally the OL will tell us that it has an alcohol present. Now we're still going to do the same thing. We're going to have the carbons drawn together just like this. You'll have your dots surrounding it, that the hydrogens and now the alcohol will attach to it. Now the other thing I want to point out here is that it does have an alcohol, and the question is, where does the alcohol go? Well, you have to pay attention to the number that's in front of the name itself. So 2 tells you the carbon that it's going to be found on. Now in this case here, we're going to number the carbons here, left to right. It could be done the other way, right to left. It does not matter. But what does matter is the fact that the alcohol is found on the second carbon here. So you have the alcohol group here. Now what goes around the rest of the carbons? It's simple hydrogen. So you're going to fill the hydrogen around in every other carbon that has a lone electron. So just like this. Now what exactly if we go back to the other example here, 1-propanol, what do you think the formula would be for that? What do you think the structure would be for that? Now that's something I want to just talk to you quickly about the 2-propanol, just so you understand how to write the formula from this. So keep it simple. Don't try to say C3H-OH. Sometimes that can be confusing. Just write it out the way the Lewis structure is. So you got CH3, CH, OH in parentheses here, and then CH3 on the outside. So you have the first carbon, the second carbon, which has the alcohol group, and then the last carbon there. So let's do this 1-propanol right fast here. Need some space. Alright, so we're going to have 1-propanol. Alright, let's see here. Alright, now again, the prop tells us that we have 3 carbons, so we're going to go ahead and put that 3 carbons there. You're going to have your dots around, and then just like we saw earlier with the 2, you're going to number left to right, say 1, 2, 3. Since it says 1-propanol, well, the first propanol is going to have the alcohol group attached to it, and then you'll do the surrounding with hydrogen just like we've seen previously. Alright, so that's going to be it for today, guys. I hope that you learned something about just naming simple organic compounds, and we'll see you in the future.